Hey, welcome to Zona Mechanica. There is an MCQ on bending stress. Figure at the margin indicates the weightage of the question, that is 1 mark. A cantilever beam has the square cross section of 10 mm by 10 mm. It carries a transverse load of 10 Newton. Considering only the bottom fibers of the beam, the correct representation of the longitudinal variation of the bending stress is, there are four options. The bending stress, how the bending stress will vary along the length of the beam. So these curves are showing that nature of the variation. So this is the beam of a square cross section 10 mm by 10 mm. Okay, so this is the cross section of the beam and this is the length of the beam. The load is acting at the mid span of the beam. Let this is the point A, this is B, and this is C. So clearly the part AB and BC both are of 1 meter and both will show two different types of variation of bending stress. So in option, this is the length of the beam, length axis, okay, and this is the sigma, that is the bending stress, okay. So from the well-known bending formula, sigma by y is equal to m by I, we have sigma is equal to m into y by I. So where y is the distance of the mid fiber from the bottom side, so that is 10 by 2, right, 10 by 2 mm, and I is the bd cube by 12, that is 10 into 10 cube by 12 mm to the power 4. Okay, so these two are constants, so only m is the variable, so sigma varies with m is nothing but the bending moment. Okay, so now we have this right hand side portion. Since in this portion there is no support reaction or any other external resistive force, so the bending stress is 0 in this portion. So in the four options, the second part, okay, so second part all are showing 0, sigma is equal to 0, right, sigma is equal to 0, and these are the maximum sigma at the end A. Okay, so sigma is equal to 0 in the right hand side portion of the beam, so which is correct in all the options. Now the left hand side portion, that is AB portion. In AB portion, if we consider a section at distance x from the loading point, okay, then the bending moment will be, let's suppose at this section bending stress be sigma x, then m will be 10 into, that is the load, 10 into x into y by I, right. So y by I, this is constant, as you can see from this, since the cross section is uniform throughout the length of the beam, the y is also fixed and the I is also fixed. So only variable is x here, that is sigma is directly proportional to x, that is the distance of the section from the loading point. The variation of the sigma with the length will be a linear nature. Okay, so this option B and option D is showing a parabolic curve, so which is wrong, and option A and option C is showing a linear nature, that is the linear variation, sigma is varying linearly with the length of the beam, so which is correct. Now the value of the magnitude of the bending stress at the end A, that is the maximum bending moment, bending stress, will be 60 MPa or 400 MPa. So let us calculate. At x is equal to 1 meter, right, 1 meter. So what is the bending stress? So 10 into 1, this is in meter, so I am taking in millimeter, okay, into y, that is 5, and I is 10 into 10 cube by 12, so this is Newton per square millimeter. This 10 to the power 4 into 5 by 10 to the power 4 into 12, right? So 10 to the power 4, 10 to the power 4 gets cancelled, and this is 60, and this Newton per square millimeter is nothing but the MPa, right? That is 60 MPa. So which is matching with option A. That is, the option A is the correct answer.